All right, so should be recording now. All right, so to install, just to go over this again, you can go to wolfram.com. If you're on your laptop and you haven't used it before, you can go here to get the software. I think either way you would come here. If you were going to download it, you can download it from the site. Otherwise, once you log in, I think you can just access it on the site. Is there some sort of icon for you up here that allows you to log in? Do you guys see that? You're already logged in. Anybody else? You're already good to go. And you're using your laptop for the first time, is that right?
Mm-hmm.
Are you able to log in on the website? Does it look different or?
No, it looks like that. So I am.
Okay, so if you click up here, maybe it's your account or I'm not sure. Let's try this. Now I'm logged in on my Selwyn account. And up here I should see my products. So I can see Wolfram Mathematica and Wolfram Mathematica. So this is my, I think they had upgraded me before we started, before they had version 15, and I think this would be my version 15. So I come here, go ahead and click that. Do you guys see some sort of product here?
I signed up in. How would I download?
Up at the top, do you see my products?
Oh, my wrong.
You also don't need to download.
Yeah, on the laptop you don't need to download, but I'm just showing you when you have your desktop at home, how you would download. And then you should see Wolfram Mathematica.
Well, there's a kind of conflict because I'm already signed up with that one. So, like, would I-
Yeah, that's okay. You get 2 installs, but you can still.
Oh, 2 installs. That's
Yeah.
I can only install twice.
Yeah, but on your laptop you don't actually have to install it. You can just use the web-based. So you're going to click on Mathematica here, and then you notice that there's 2 options. There's download the desktop app with the documentation, the help built into downloaded on your computer, so you don't need an internet connection. And when you pull it up, it pops up a window that you can read. Otherwise, it'll pull up the website. That was that very colorful main menu, and you can use the web-based documentation.
So you just download a link to the website.
Yeah, I would probably go get the local documentation so you don't have to have the internet to use it. Not that you wouldn't have the internet, but yeah, pick one of these. It'll eventually ask you to activate. It may not. It may just like pop open your web browser, and if you're logged in, it'll do the activation for you. Otherwise, you will have to activate it yourself. Another way you can do this is just to download the free trial. I don't think that'll have the documentation built in. And then there'll be an option on the free trial to activate it. You can click that, and it might open up a browser window and ask you to log in and do it that way, or it will ask you to enter one of these activation keys. Does that make sense? So I've installed it, I think, on my laptop, and I can now install it on a home computer as well. And you can access it on the web. So right here you see web. Go to Mathematica. If you're using a laptop, just go ahead and do that, and it should open up a virtual notebook. Not a virtual, but like a web-based notebook, and we can run that from now. So you installing it on that PC?
Yeah.
Very good.
I'm probably just going to send it on the website on that.
Okay, well, you're not going to use your code. Maybe Brady could use his code here. So do you guys, or did you install yours on one of these so far, Brady?
No.
Maybe next class we'll worry about that, and we'll get an install here for everybody. But then you'll have kind of an assigned PC here, an assigned workstation. That way you have that. If there's a problem with the internet, the Wi-Fi goes down, we can still operate. Does that make sense? Very good. If power goes down, we'll be in trouble.
Well, I feel like we need to be able to get off work.
Yeah, but it'd probably be too hot to be at school at that point. But don't get any ideas. You look like a devious smile there. When I said if the power goes out, we might not be at school. Uh-oh. Vandals all of a sudden this weekend. Okay. Are you
Starting
get?
to download.
It started down there? Okay, so for now, you can follow along on the laptop, or you can, I'd say follow along on the laptop for now. Again, I am screen recording. Hopefully the audio is captured so that you guys can follow along.
How would you access Wolfram via website?
Same way, you're going to log in, right? But now do you see down here where it says web, go to Mathematica?
I see.
Very good. I am going to pull up the, let's see, I'll hide OBS for now. I'm going to pull up the app that I have installed, which went away. I don't, why did it, I didn't pin it, I guess. So Wolfram, I couldn't replace the old one, so I had to install it twice. So this is now the new one, Wolfram 2. But if you have installed, yours will be on Windows, so it'll be a little different. You should get this sort of launcher at the beginning, so you can kind of see a getting started guide. That's something you can explore. There are courses. A lot of them are free. So some of them are just kind of like you watch some videos, you do some things. It's like a free sort of tutorial type courses that you can find. Some of them have instructors. So if you guys remember the second day of class, I had a sort of webinar that we were logged into, and that we saw that guy kind of doing stuff. I should have access to his webinar to download, and I can watch later. That was over, I believe it was titled High Impact Visualizations. So he was showing how to make really nice looking graphics. That's actually going to be the concentration of what we're looking at today is visualizations. But you can find things here. Community is like a forum, I assume, where you can ask a question, like how do I do this? There's the documentation. If you download it, it's built in. Otherwise, it'll link to the website. And it probably has your recent files here once you start making files. But for now, we're just going to hit New Notebook. And if you are on the web, you should have a website sort of notebook. Are you into something?
No.
You're going to use the notebook today?
Yeah.
Okay. So we're going to save today's thing. I don't know. We could call it, is today the 4th day of class, technically?
Yeah.
So we could call it class 4. If we want to, I'm just going to save that. Control S. And I'm going to say, okay. That's my other Wolfram install. I'm just going to say class 04. I'm going to put a 0 because we will break 10 before the end of the year. Okay, it keeps telling me Wolfram is damaged, but hopefully it's not too much of a problem. Oh, you know what? I did not look at how to force this thing to stay zoomed. So I apologize for that. Screen environment, style sheet, other size.
The website, there's just a view option in the top right. That gives an application.
Yeah, but for me, it's like per cell. So every time I go to a new cell, I got to do it again on this desktop version. Window, zoom. I think that just maximizes it. Anyway, I'll just keep making it big for you guys. Hopefully by next class, I'll remember to look that up and how to fix it. What's this? Search. Okay, anyway. All right, so the things I want to go over today are stuff that we've already kind of gone over. I was just trying to throw in all these different possibilities at you last time and the time before. We're going to try to be a little bit more systematic and hopefully you will follow it if we just keep adding little bits to it. All right. Do you guys remember? Well, first of all, just to go over just quickly entry stuff. How do I perform, let's say, 1 plus 1? Do you guys remember that? How I would execute that? Can you do that on your computer here? I want to know what 1 plus 1 is, but I'm too lazy. I want the computer to do it.
Yeah,
One plus
it's
one,
just
shift
one.
enter?
It's just
Shift enter. Very good. Yeah, 1 plus 1. Oh, let me make it big. 1 plus 1. And then shift enter executes, right? And then you see the input and you see the output. Okay? If I want to, what's a more complicated addition problem that we'd like to do?
1 plus 2. It's possible to just do the Fibonacci sequence, or make it recurring to certain.
Oh, okay. Yeah, we'll get there. We're not going to do a recursive algorithm yet, but that's a good idea. We should do that. 3,000. Oh, let me make it bigger again. 3,000 plus 4. Shift enter. What did you get?
3004.
Very good, very good. All right, now what I want to do is find the factors. Actually, I'm not remembering how to do this. I think it's just factor. I want to factor this number, so I'm going to hit %. I'm going to make it big again. And that, do you guys remember what % signify?
Like previous.
The previous output. And then I want to feed that output to a function that I believe is called factor. So I'm going to hit // and I got to do capital for the built-in stuff. I'm going to say, oh, factor integer. Let's do that. And then shift enter. And what did you get?
I get 2 dash 2 and curly brackets and then another 751.
Did we all get that?
Yeah.
All right, so we just factored the number 3004. Do you guys know what this means? Can you interpret that? What does it mean?
When it's 751 times 2 twice.
Very good. Yeah. There's 2 factors of 2, and there's 1 factor of 731. So it's kind of exponential notation. It's 2 squared and 751 once. Very good. And you're seeing also in this output that lists, when we have a list,
How does 751 make 3,000?
it's 751 times 2 times 2.
So 1502, 3004.
And then
Are we just basically?
the 4 is.
Yeah, 4 times 751 is, so 750 times 4 is 3,000. 1 times 4 is the extra 4.
Okay.
Are we following?
Yeah.
Okay, curly brackets are how we do lists in the Wolfram language. And if we wanted an XY pair, a coordinate pair, we would use curly brackets for that ordered pair. And in this case, they're showing us powers of 2 and powers of 751. They're using curly brackets again. So we have lists. We have a list inside of a list. All right, so let me also show you how we can enter stuff. I'm going to type in, let me make it big again, 751, right? Now, in most programming languages, you'd have to hit Shift 8, and you would get the asterisk, right? And then we're going to say 2, and then Shift 6 gives me that caret, and then a 2. So this is 2 to the 2nd power times 751. And you can Shift enter that, and we should get our original output. Did that work for you?
Yep.
Okay, one of the reasons why I wanted to use Mathematica for this course instead of like the free alternatives or some other paid alternatives is I really like the way that we can enter stuff. We can make it look like it looks in the textbook. It doesn't have to look like this programmer's version of it, right? So go ahead and type 751 again, and then just hit space. Now, Mathematica should interpret the space as multiplication. But just wait. And now, instead of 2 Shift 6, go ahead and hit 2 Control 6. And you'll see now you get a little box up there.
Which is control. Okay.
The one that says Control.
No box shows up.
Yeah.
On the web version?
Yeah, no.
Okay, try this. If you go to your palette,
Palette.
is there a palette is there a menu ribbon with the palette option?
No.
Not on the web version?
No.
Oh, I'm sorry. See, this is why I want it installed on desktops. It's
Yeah.
one when you manipulate, it's very smooth. On the web version, it's very choppy. So it doesn't feel as good.
What's Square supposed to do?
Well, yeah. So it lets you type. It's a text box, so I can put a 2 up here. So it's 2 squared, right? It's a 2 to the power 2.
So it's basically just a visual.
It's kind of like when you get a newer calculator. It allows you to do that sort of multi-view or math print, whatever TI calls it.
Technically don't need it.
You technically don't need it, yeah, but it is nice. So go ahead and Shift Enter. You'll notice that the space became a crossbar, and we should get the same result. Is this all making sense?
Yeah.
Okay, if you don't have the palette, there is a way to create symbols like Greek letters. Sometimes you want to use a Greek letter for your stuff, like let's say theta. Like oftentimes theta is used for angles. So you can hit, I believe, let's hope it works for the website, I don't know. I'm going to hit Escape, and you should see like 3 dots. Do you see that on the website?
Yeah.
Wait, which one did you press?
Escape.
Oh.
And then I'm going to type in theta is the Greek letter for, we don't have this letter in English, it's TH. So I'm going to type TH, and oh, you can do slash too, that works. And then if you hit escape again, it becomes a theta.
Whoa. Okay.
If you hit space and escape, you get alpha. However, if you do escape, you get pi. And pi is a constant, so it's not going to be a variable. That's actually reserved for the pi we all know and love. I'm going to delete the other symbols and just leave pi, and let's execute it.
Option P also works for pi.
What is that?
Option P also works for pi.
Option P?
Yeah.
Really?
So pi is.
It doesn't work for me. Okay, so did you execute the pi?
Yeah.
That sounds like you just demolished a pie. I executed it. Notice the output, was it just pi? So that's an exact representation, and the only way to do that is symbolically. But again, if we feed this to the function, so if I write n, so I want a numerical approximation, n, and then I feed it using these square brackets, yeah. And it should give me a decimal approximation. But I want 1,000 decimal points, so I'm going to say comma 1,000 after the pi. And you get a lot of pi.
Oh.
Don't go too big, otherwise you'll crash. I don't know.
Whoa.
Let's not lose our minds here.
I mean, how bad could it end up?
Do that on your own time when you can restart. Let's not, yeah, let's not do that during class. Okay, so we can get a numerical approximation. Also, if we do 1 divided by 2, so let me make this big again. I would do 1/2, right?
Yeah.
And let's execute that, Shift, return. And the bottom of my 2 is kind of missing, but I can see the output, right?
Yeah.
Just try 1/3. Now 1/3, do you know what that is as a decimal?
Yeah.
1.3.
Point. It's 0.3 repeated.
Yeah, 0.3 repeating. But so it never ends. So Mathematica is going to show us 1/3 as an exact representation. not as a decimal. 2 4/6. Now that's because 3 is considered a perfect number. Like this is exactly 3. Like if I measured something and it ended up being 3 centimeters and I called it 3, that would be a measurement, which means it has what we call error. There's always error in measurement. So I can't actually measure something as being exactly 3 inches. There's no such thing. What I can say is to the level of precision that my ruler has, that I measured it to 3. You know, I measured it up to 3, but it could be 3.0000000106019. You know, like it could have a little bit off of 3. So if I change 3 or 1, if I just add a decimal, then I'm introducing a level of precision. And if I run that, it's going to now treat it like a decimal number, and it's going to show it to me like this. So that's one way to kind of force it to do decimals, is you can just put a decimal in your numbers, and then it knows that, oh, that's not just 3, that's 3 give or take. That's 3 to a certain level of precision. It's not a perfect 3.
And could you also do the bracket with housing?
Yeah, you could do n with 1/3. Let's go ahead and do that. So I'm going to say n. Oh, let me. Capital N. Every time I delete the line, it. Oof.
Whoa.
I hope you guys can see this. And then inside of here, I'm. You take your glasses off.
1 second, I can't see it.
Still?
Really?
Well, if I take my glasses off, I can tell there's white there. I can't make out anything.
Wow.
I can see a bit of white on the left side of the screen.
How many fingers am I holding up?
Still see.
How many
Okay.
fingers am I holding up?
4.
Dang it.
How many fingers am I holding up?
No clue.
Okay.
Okay, all right.
Okay.
His eyes are
Let's
bad.
stop.
I think we've established this.
Aw.
Okay, if I say 1 divided by 3, like 1/3, right? What if I don't want it written that way? I want it like nicer. So I'm going to do 1, and then instead of slash, I'm going to do control slash. And now I get a tiny little box down there, which hasn't adjusted font size apparently. And if I do 3, yeah, on the, are you kidding me? The little 3, I got to manually adjust its font size. Okay.
Yeah, it doesn't work.
So, is this the same as?
I don't know what I
slash
just
3?
did. You know what? I'm just deleting this.
Yeah,
So I have a
that-
question mark and accident.
So is this the same as 1/3?
Yes.
Okay, cool.
There, that looks maybe close. So yeah, it gives me the numerical approximation. I could say I want, why, this is making me angry. If I want 1,000 places, I can do comma 1,000. This is just ridiculous.
You can do the Apple logo.
Did you? Do you just type Apple?
No. Shift Option K. Get the Apple logo.
I didn't get that. No, I don't know how to do that. All right, so very good. So you can make things look nice. Otherwise, if you have access to the palette, you have like I can make a fraction type. I can do the powers this way. You can get the pi symbol here, E, I for the imaginary. You have different type settings, so you can create different formats. So you can do underscore and stuff like that. You can get matrix looking stuff. So we can use that in the future.
And that's out there. Is that on the website?
I don't know. I went to palette up here and chose a basic math assistant.
Oh, I don't have palette at all.
No?
No.
Okay. See, I like the installed version. I've never really liked using the website, but
If anything involves
There's
palette, I
inserts.
cannot use it.
there is insert.
Yeah, you can use special characters and get that.
Okay. I think the escape P, escape, that's a way to get some of those Greek letters and stuff. I think if you do escape, double E, escape, that gives you the,
What is that?
the natural number E. Sorry,
What's that?
it's a double struck E, so it's representing the the Euler's constant.
Is that the escape key?
So if I divide that by 1 decimal,
Oh, got it.
then it will show me that it is 2.7182, and then it's rounding at that point.
How does that work?
I will explain that to you at some point in this class, what E is. We will work with
Extra.
compound interest and stuff like that.
We
So-
not.
We are, yeah. At some point, not today.
I did not know that like the British pound symbol was called sterling.
Oh, yeah. Pound sterlings, yeah. That's a pound, I guess it was a pound of silver at some point, I guess. Sterling silver, maybe? I don't know. I don't know where that name comes from.
I don't know the absolute fact. I know a lot about that one.
Our dictionary of obscurity has been exhausted. Okay, so let's go over some lists and table type stuff. So I'm going to, again, if we want a list, we use curly brackets. We can generate lists in a few different ways. One was using range. Do you guys remember that? So I could say I want numbers in the range of 11 to 231, and I want to count by 7. And now I start at 11. I skip at, I go 7 steps in between, and I stop before I pass 231.
And if you do table, range, and curly bracket table, curly bracket, curly bracket.
Yeah, if I do table, I can specify a formula with a letter in there, a variable. So maybe I want I squared. I'll use control 6 here. So I squared plus, I got to go right to get out of the exponent, plus maybe I cubed. And I want this for, and then I specify, I do comma, and then I put a curly bracket list here, and I'm going to say I is my variable. I want to start at 0, let's say. Oh, let's start at 1. And I want to go to 5. Or let's go to 10, but I'm skipping every 2. So I go 1, 3. I should only get the odd numbers. If I run this, I get 2, because if I plug in 1, it becomes 1 plus 1. And then the next number is 36, because at 3, I end up getting 9 plus 27. And it keeps going. I think it ends at 9. So table is a really nice way to generate a list. So let's use that list real quick. I'm going to say, I want to visualize it. So I'm going to say list plot. And I am going to say, out with a capital O. And in square brackets, I'm going to type, for me, it's out 16 was here. So that was my last output, was out number 16, the output number 16. Is this not, let me make it bigger, sorry.
Just out.
Yeah. So do you see to the left here, for me it says out 16. So I'm putting out 16 here, so it knows that's the list I'm referring to. And that's all I got to do. I just list plot, and then if I run that, I get my dots.
Whoa.
Is there a reason why instead of a plus on the website? Or I'm just wording this wrong?
I can look.
Because where is exactly the and the only thing that's marking as something is
Is this an image for you?
Oh, for you, it was out 9. You don't have an output
It's
16.
just an image.
Okay.
Oh.
Charlie, is there still, can you actually see it on?
You need another square bracket.
But
think it's just your laptop, right?
I just wanted to see it. It's in
Thank
the
you.
It's just an image.
What's your problem?
Oh, there are images.
There is no problem here, officer.
It's not really an image.
We are not doing anything.
It is an image, you can save it, right?
No.
What
I
is
actually can't
that?
say it. The inspecting.
Oh, yeah, it isn't an image yet, right? It is, can you select it? Can you hover over it and it tells you oh, for you, it's that way. So
Yeah.
for me, I think I can interact with it on the desktop app.
Charlotte can, but me and Isaac can't.
Okay, so that's another limitation of the
Charlotte can actually
web-based
see read
version.
on the points on the graph, right?
I can't lie.
I can see him with
So,
my
so the
eyes.
point of the web-based version is if you have like a very crappy little Chromebook with no CPU, you can use Wolfram's servers to do your calculations for you. So you're not actually performing the calculations locally on your machine. You're just sending inputs to the server. The server's crunching the numbers, and then it's sending you the results. So you're supposed to, on your end, have a very low computational, workload.
Yep.
And you're just transmitting data back and forth to the server. So it's sending you pictures, but you're really, it's prepared to work with a very limited computer on the client side.
It's supposed to work on any computer. That,
Yeah, I mean.
that's actually just not being held together by tape.
Yeah, right, yeah. So I don't know about the website, but on this program, if you can resize your image, and I believe it stays like decent resolution here. Probably for the web-based one, it might get pixelated, I don't know. It maintains the aspect ratio, but if you hold shift while you resize it, so if I hold shift here, then I can change the aspect ratio. You notice my dots are getting kind of big here. How does that work on the website?
If you hold shift, and it does.
It won't change the aspect ratio.
If you hold shift, it won't?
No, it
Okay.
just,
Not doing anything.
So you get an image and you can't really manipulate it after that.
Yep.
Very good. I don't remember how you do point size here. Let me see if it works. I don't remember how I'm supposed to enter this. Point size, arrow, 0.25. Nope, it didn't like that. I don't remember how to do this. Is it brackets? Let me try this real quick. Do I have to do an epilogue? Don't follow me here. Let me just try to. Point. I don't think that's doing anything. Anyway, forget that. Is this okay?
yeah.
You guys follow? Okay. I am going to. We can remember. You can do filling, arrow, axis, sorry, and it puts in little lines. I am going to double click on list plot to select it, and then I am going to hit F1, shift or function F1 on my laptop to view the documentation. And you can see if I scroll down in the documentation, there are options and applications. These are always cool to check out. Let's see if I can figure out how to change is it plot style? Here we go, plot style. That's what I want to do. And then I can say point size large. So I'm going to try that. So that's always a cool thing, is to check out what you can do in the examples that are provided. So I'm going to say plot style is an option here. And I'm going to say point size 0.5. Oh, 0.5 is big, okay? There's my big old points. They're like moons. That's no moon. Do you guys know my movie quote? It's Star Wars: A New Hope when they see the Death Star. It's like, that's no moon. Anyway.
Okay, it's not. Oh wait, no, I did the wrong thing.
I was talking to a teacher and just yesterday, and they're like, "Oh, I have to go duty. You're lucky you don't have to go do duty." I was like, "Well, not like that." I'm like, wrong crowd. Sorry. All right. Is this making sense?
It's yeah.
We can also color. So instead of one imperative or one directive to this guy, I could do curly brackets around that. So plot style, and then I'm doing curly brackets. And then I can put in a color. So let me show you guys, because I know you're going to want to control color. I can just type in some named colors, which I don't know what are the named colors. The what?
The ones with like rainbow.
That one, you're going to have to read the documentation. I don't remember off the top of my head, but if you look up color function, so if I hit function F1 here and I type in color function, here's the rainbow, and it looks like it's a function that's based on the variables. I'm not sure how you do it with list plot. We'll do an array plot soon. We'll check that out. But you might be able to find applications and copy some of this code, play around with it, and kind of figure it out. It may work better if you look up plot, like if you want to plot a function, which we will get to soon. So when we get to it, I'll check that out. And then under here, if you go to options or applications, maybe plot style, you might see here's an example. So we'll get to this when we get to plot. Okay? So magenta worked. You can also specify your own color. There is something built in called RGB color. So, and then I guess I can have a little color chooser right here. That's nice. That's new. I don't know if the web version has that. But in the RGB color, I don't know what goes in here. Let's see. Does it accept? I feel like it's 0 to 1, so 0 to 100%. So if I wanted all red, I could say 1, 0, 0. And a red, or I can mix some red and some green. So maybe I'll put a 0.6 here for green, and I get this orangey color when I mix red and green. So you can mix red, green, and blue. Is this making sense to you guys?
Yeah.
Let me know if you're able to create a color.
I got a pink.
You got a pink? I like.
Orange. Oh, I just.
Yeah. You could mix maybe green and blue. Get kind of an aqua going on here. I got a teal. Maybe I want more blue. I'll do 0.5 here. Yeah, I like that. Okay. Well, this is how you mix them. There are some named colors. I don't know what they are. Let's see if I can pull that up. If I type in color data, and then if I put in quotes the named colors, there's sets. So there's different sets. So I could talk about atoms, I guess. That didn't work. Oh, I have to do maybe double? I don't know how this works. No. Named atoms. Okay, so then if I index them, I don't like that. Anyway, I don't know how you get to those. That's something you can look up. If you put into like one of those search bars like Google or DuckDuckGo, you can type in like Mathematica, what are the named colors, and the AI is pretty good at giving you answers. And then we do have access to this Wolfram AI, which we haven't turned on yet or played with. So I've never used that before. I will try to look at it this weekend, and so by next week, hopefully I can help you guys integrate the AI workflow into your Mathematica works. Okay. All right. All right. We're just kind of going through stuff that hopefully you guys remember. I want to show you guys some more graphics primitives. So before we get to plot, let me show you guys some graphics primitives. So I'm going to type in circle, and I'm going to open and close square brackets. Let me make that bigger. Sorry. Oops, I got to select it in order to do that. Okay. All right. When you feed the circle function no attributes, no arguments, it produces the unit circle. So it is centered at 0, 0, and it has a radius of 1. It is a sort of graphic primitive, but it is just in memory, so you don't see it, right? You're just seeing it. Just outputs kind of like circle, right? Is that correct? Okay, so the way to see it is you have to wrap it in graphics, a function called graphics. And now it shows me that circle. Is that okay? All right, I believe I can give graphics more than one thing to show. If I wrap it, I think I need to make it a list. Let me try it without a list. I think it'll not like that, but let me try it. I'm just going to put a comma. I'm going to say circle. This circle, I will also have it at 0, 0, but I'll make its radius 0.5. So I should have a half circle inside of this. And it didn't like that. So I have to make these circles a list of graphic primitives. So I'm putting curly brackets around that, which is inside of graphics. When I do that, I can see both circles. So you got to put the curly brackets around your list of circles. If this is difficult to read, one thing you can do is say you can do line breaks. So inside of graphics, I have curly brackets. I have circles, my first thing, and then I can break these lines so I can kind of see. So graphics, and when I click here, you see that graphics is highlighted and this square bracket is highlighted. So I can see which square bracket goes with which. And then in my list, I can see I got a list, and my first element is a circle, and my second element is also a circle, same center, but a smaller radius. So you can do line breaks, which may help you make it readable to you. Does that make sense what I'm talking about?
Yeah.
In this list of graphics primitives, I can put in things before the graphic element. So I could, like options. So I can say pink. And then before this one, I can say red. And you'll see that the outer circle is now pink. And then it switches to red before it draws the inner circle. I can also add things like thick, maybe? Or thickness 2. I think 2 is too big. Let me let me try 0.2. Yeah, 2 would have been huge. Maybe I'll do 0.2. There we go. So you can put in like different sort of options here, and if you do it before the next thing you want to make, it'll apply it to what comes after. I can also say dashed, and that's kind of a dashed line. Here, this one I could say dotted. So now I have a dotted circle. Maybe I'll give that a thickness of 0.01. Maybe I'll do 0.04 here. This weird stuff. So the idea here is that there are some graphic primitives, like circle. I'll show you some other ones soon. And if you want to see it, you got to put it inside of the graphics function. If you want to put in more than one, you need to give the graphics function a list of these primitives. And you can even put in options into that list. And it will affect what comes next. Is that okay? Okay, I want to show you guys another set. So I'm going to say, let me make it big. Graphics. And I'm going to press enter twice here so I can do the line breaks. I'm going to do curly brackets so you can hopefully make it a little bit more readable. And then I am going to show you guys a couple different types of graphics here. So the first one I want to show you is line. Line is a function, so I put square brackets after it. And then inside of those square brackets, I'm going to put in a list of ordered pairs, a list of points. So I need a curly bracket for my list. And then in here, I'm going to put curly brackets and more curly brackets. So I'm going to say a line from -1, 2 to 3, -4. So those are my XY coordinates. So start up and to the left and end down and to the right. And I can shift enter and I get this box. You can't really see where I'm at, but and the aspect ratio is probably not correct, but
Why is there just a line?
what's that?
Why is there just a line?
Just because I made a line. That's but I can add in some other things. So I'm going to also add. I'm going to copy that the line part. Did you guys all get a line? Let me wait until you guys get there.
Yep.
We're good?
Mm-hmm.
Okay, I'm going to put a comma after line and add a second graphic element. I'm going to paste the same thing, only this time I'm going to change it from line to arrow. And I'm going to choose different starting and ending points. So I'm going to start this one at 0, 0. And I'm going to go to -1, -2. And now I get a little arrow. So these arrows are going to be pretty big. We can do a lot of things by drawing arrows, as you will see in the coming classes. Is that okay?
Yeah.
Again, you could make circles like we did up here. You could add a circle to this list. If you do a disk instead of circle, it fills it in. I'm going to show you guys polygon. So I'm going to paste again. And I have my line again. But instead of line, I'm going to make polygon. And this time I'm going to give it 3 points to make a triangle. And I'm just going to make up 3 random points. So I'm going to do like -2, 1, maybe 0, -2, and 3, 3. And so I get a polygon. If I want it a different color, again, pink, the polygon can be a different color. The last thing overlays the others, so it covers up what went before. If I did them in a different order, the arrows could be on top of the triangle. Are you guys okay with this?
Mm-hmm.
All right. We're going to look at plot now. And this is going to be kind of what your assignment will be based off of. You can combine some of this other stuff with it too if you want. I'm going to want you to generate a plot of some sort. So,
What did I do wrong?
you got a problem?
Yeah, for some reason this isn't working.
Let me take a look.
Because nothing's showing up, right? It just says can be followed by 3, 3.
Need a comma there?
Yeah. And it says oh.
Well, you have a period here. There you go. Okay. All right, so the next thing we're going to look at plot. So plot, it's a function, so I'm going to give it the square brackets, and I got to feed it stuff. In the first case, I'm going to put a comma because we have two parts that we necessarily have to have. We have, again, you don't have to use x, you could plot any variable. But on the second side, you're going to create the domain. So I'm going to do a list. I'm going to say x from -10 to 10. And that is the range that I'm going to plot my function over. To the left of that, I am going to put in a function of some sort. So here, I'll try 2, and then I'm going to do Control-6. And I'm going to say minus x squared. What did I do? I don't I don't know what I just did. Minus x squared. And then I'm going to multiply that sort of weird little exponential by sine, and I got to use a capital S for the built-in functions. And I'm going to say sine of 6x. And so I have this weird little function here, and I want to plot it over the domain -10 to 10. It looks kind of weird. Okay, maybe I'll do 3x instead of 6x. It's still very, I think I'm not seeing all of it. So let's put in a plot range so I can decide what it goes to vertically. So I'm going to, so are you guys good with this? Did you guys get this plotted?
Yeah.
Everybody? Okay. All right, so this is the basic plot. So let's hit Control S to make sure we don't lose our work. So let's save class 4 right now. And then I'm going to copy this line, and I am going to paste it down here. I just hit Command S. I don't know if you have a button or something up top, like a little disk icon, or
Doesn't look like it.
do you have like a cloud with a check mark? Does the cloud automatically save your work from time to time? Let me see here.
I know it saves your recent files, but I don't know.
So it says on main. If I go to File, I don't know how to save it.
I'm pretty sure auto saves.
It should auto save. It should indicate that it's saved, but
I just downloaded it.
I don't see it. But I will explore that for you.
Yeah, it auto saved.
Okay. All right. So I'm gonna leave that there. I'm making a copy because I want you guys to have just like a basic plot input. But now we're gonna get a little bit more complicated and add some options. Okay. So I'm gonna say comma, and I'm gonna press Enter twice, and that way you can see every line of options that we're adding. So the first one, I'm going to say plot range arrow. And then in curly brackets, I'm going to say, what do I want my minimum y value to be? And what do I want my maximum y value to be? I am going to go from maybe -2 to 2. And now I can see the graph look a little bit different. Let's go from -1 to 1. That might give us a little more detail. And I'm going to make it 6x again instead of 3x, so I can see a little bit more, or let's do 4x. There, I can see a little bit more. So I just did the plot range from -1 to 1 vertically, so I can see the top and bottom of this thing. It's a little wavelet in the. Let's draw it out. So. There you go. Yours looks good. I'm going to draw out this little envelope that it's in, that's all stuck in between. So up here in the exponent where it says -x squared, I'm going to divide that by, whoops, I'm not up there. I'm going to divide that by 10. And so it widens the envelope for me. And maybe I'll go to 3x again, because now I can see more of it, and I don't need that many waves. So I just have a little wave packet. Did that work for you guys?
It made it a lot smaller.
What do you mean a lot smaller?
Since you don't have the exponential box, you can't divide just the exponent.
It just made the same
Oh,
thing, but straightened up the lines.
Yeah.
You need to wrap the -x squared divided by 10 in parentheses, so that the divided by 10 is part of the exponent. Nope, go to the right one. That works. There you go. Very good. Nicely done.
It's just
There you
making
go.
the same thing.
There you go, that works.
It's still making the same thing.
Is that a problem or good?
Yeah, because under
Okay,
it's not a straight line.
So,
it's
so this divided by 10, it doesn't know it's in the exponent, so let's wrap all this in parentheses.
I thought that.
There you go. Okay? All right, I want to show you guys some more options for your plot. Charlotte's figured out the rainbow thing. I'm going to put a comma and press enter to add another line of options. I want to get rid of the axes, let's say. So I'm going to say axes, arrow, false. And I just have my little wave. That could be a tattoo.
It could.
We could say filling in -1 if you want, and now I fill in between the curve and the y equals -1 line, so it looks like a ripple on water. If you like that, you can keep it. You don't have to keep that. We can put it in a frame, so I could say frame arrow true, capital T, and now I have it kind of in a box, and I can see locations with the box. Does that make sense? You can add, these are not things that necessarily are going to make it look better, it's just things you can add. I'm going to add grid lines, and I'm going to say, I'm going to create a list, and I'm going to have a list for my X grid lines and a part for my Y grid lines. So I can choose where I want the grid lines to appear. Oh, that's weird. When I do this, the TV looks ugly, but my screen doesn't. Oh, that was really weird.
Yeah.
So for the X grid lines, I'm going to put a grid line at -5 and 5. It may be 0 as well. Let me put 0 in there. And for my Y grid lines, I'm going to do the same thing, -5, 0, 5. And now it's hard to see on the TV, but I'm getting grid lines
It doesn't work.
on the computer.
Yeah, on the website, I don't know if
It
it's.
works.
Let me see if you typed it in correctly.
Oh.
There you
7
go.
error things
Nope.
and they just disappeared.
Oh, you
If
closed.
you inspect the page, I currently have 33 errors apparently.
Oh, what's the inspection?
92%.
Double click.
Yep.
Just double click it.
Yeah, just.
It's taking
Right click.
progressively longer to
So,
load
right
every
click.
time I
Oh,
try to load it.
okay, yeah.
Inspect. I currently have 33 errors.
How do you see that? Where?
Top right of that.
I didn't expect it to have that.
Right click.
Right click.
Should be at the very top. Section bar.
For all this stuff?
Complaining about the.
Oh, you need a
Not
comment.
the code button.
He has one mistake, I have 60.
Yeah, I'm not
Yeah, I have
seeing
33.
the Y at -5 and 5. I'm not seeing.
I-
Oh, the Y needs to be 0.5s, not 5. Sorry about that. So Y needs to be -0.5 and 0 and 0.5. I was off the graph for the lines. All right, so there. We got that. We can do plot style. So I'm going to do a comma, make a new line, plot style. And to make a color, I like to use hue, saturation, and value. Again, you could do RGB color, but it's I have to do interpreter. I really don't like the way this works. Interpreter, and then it's HSL color, I think is how I do it. Let me see if this works. And then I don't remember how to. Let's forget this. For plot style, I'm just going to put in an RGB color, and maybe I'll do aqua, 0, 1, 1.
Are there hex codes or just RGB?
You can do hex codes, I think. You might have to feed it into a function. RGB is the only thing that has like a built-in. In order to do HSL, you have to tell the interpreter that you're giving it hue, saturation, and lightness. So it's like a function that you got to use. It's complicated. I looked it up this morning, but now I don't remember what I did.
Okay, so now the entire thing disappeared.
Actually, I should have it written on my paper. What's that?
The entire thing disappeared.
Well done.
It loaded, but didn't. So I didn't know if I gave white. Because that's a comma.
Oh, these have to be, so for 55%, you would do like a decimal.
Oh, it's percentage.
Yeah, it's not normal. So like normally,
That makes more sense. That makes more sense.
Mathematica is a little
I was wondering
unique.
why you were bidding not like actual, just like clear black.
Yeah, I know. Because it treats these as percentages. You can put the percent sign, so I could put like 100%, 100%. All right. Do we have 15 minutes? Is that when we get out of here?
Yeah.
Okay, so let me show you guys some things we can do also here. I can put plot legends, and I'm going to say expressions, which was and it's not there. Do you guys get anything?
No, but the expressions is grayed out here.
Oh, is it? I'm trying to type automatic. Automatic. That didn't work either. Okay, forget that. It's probably because the axes are off. Maybe I'll turn the axes on. Nope, never mind.
Wait, it's the S. Take out the S from the expression.
Is this supposed to put like a color bar on the side? Or like a bar on the side?
It's supposed to tell you what the thing is. Maybe it's because I have it in the frame. I'll turn the frame off and plot legends,
expressions? No. I don't know why it's not
Keep
working.
waiting, S. Sorry, last S.
Oh,
Well,
no, it
Yeah.
loads in as expressions.
anyway, it's just type. I could put like dog, and it would say it.
It says expression now.
Uh, I don't know. Anyway, I'll figure that out later. So the other thing I wanted to show you guys, I'm going to turn the frame back on. I'm going to show you guys what's called epilogue, which is, I've never really used to use it much in the past. I would do this in other ways, but it's actually pretty good. So epilogue is kind of like how graphics worked, where we could create that list of graphics primitives. So basically it's going to generate the graph, and then whatever I put in this epilogue, it'll add these graphic elements to things. So I'm going to create a list here, and inside of here I'm going to put some stuff. So maybe I will say I want a pink point size 0.03, and I'm going to say a point at I'll say 0, 0, and now I have a pink dot at 0, 0. I can also add, oh, let me know if that worked for you.
Or just put it down
Yep, and I can make it.
Oh, my God.
Did it?
Yeah.
Well, get rid of the pink maybe, I don't know. Still no?
I think I messed something up with the coloring. Oh, I forgot that column.
Is epilogue spelled wrong?
Hmm?
Why does epilogue have to be
Yeah,
spelled
that's
wrong
weird.
for the command?
It's spelled wrong for you?
Oh no, it's.
Oh, it thinks it's spelled wrong?
No, I'm saying the actual spelling epilogue is that.
Oh, there's multiple spellings. This is probably British.
I would check. Why is this more spellings? British people again.
Did this work for you guys? Did you figure it out, Charlotte?
Yeah.
Okay.
This spelling is only used in tech.
Okay. That's good to know. I never questioned it. We can also add an arrow. So I'm going to add an arrow. Again, I need a list with a start coordinate and an end coordinate. So I'm going to start this thing at 5, 0.5. And I'm going to end it at 0, 0. And I get a pink arrow pointing to it. Maybe I'll make it yellow. Misspelled yellow. Don't judge. All right. So that's my little arrow pointing to it. And then I'm going to add a text graphic with this text. Look it. And I'm going to give it a coordinate for where I want that text to be. I guess I'm going to go to 7, 0.7. Maybe 6, 0.6. Before that, I think I can say font size. Does that work? 16. Oh, you know, I know how to. Don't do font size. I can show you later how to do that. You have to wrap this text in a style function, but we won't do that right now. Did you guys get that? Got it?
Yeah, got it.
Very good. Okay, so I would say for your assignment, I would like you to find a cool looking function that you like, all right? I'd like you to plot it. And I want you to use some of these options to make it look nice. If you can figure out how to, and I want you to call out like we just did, some point on it. It could be any point on the curve. So it could say anything like, wow, you know, and
Wow.
point to something. So you can use the epilogue, you can use colors. If you remember how we did multiple plots of different functions, you could point to where they cross. But that's we didn't cover that today, so if that's too much or it breaks, just go back and look at this example. Okay? But yeah, you don't need to put in a box. You don't need, do whatever you want. Just make it look attractive to you. And then, do this in a new document. We could call it homework 1. If you're having trouble getting it to me, I want to see the code. So you can save this document and bring it in. I think you can go to File and maybe, can you print a PDF? Save it. Somewhere in the cloud, I think you can maybe create a PDF. I don't know. If I right click on this, I think I can save graphic as, and I can make this chart 1. That's now in my documents. I'd rather see the document though. I want to see the code. So I want you guys to attempt this, play around with functions, see what looks cool, and then start coloring it. Show me that you can use some of these plot options. And then if you can, with this epilogue, try to make an arrow in some text like we just did, calling out some part of it. It could be just a random part. It doesn't have to say anything in particular. Just show me that you can figure out how to make a graphic. Okay? Do you guys follow that assignment?
Yeah.
Okay, so I am going to, hopefully this recorded. So hopefully you're going to get my screen and you're going to get the audio, and I will send the link to you later, before the school day is over.
You keep on saying there's no opening.
What do you mean?
Not opening, no closing.
Oh, you must be missing a square bracket or curly bracket.
1, 2, 3, 3.
You can save this document and you can refer to your document that we just made together to help you. You can copy and paste it into a new document and start tweaking from there. But try to see if you can get some of this, not memorized yet, but just remember, okay, plot, and then I need a comma, I need a function, and I need the domain starting and endpoint. And then I do commas after that, and I can start doing options. And go ahead and press F1 and read the documentation, find stuff that looks interesting to you. Try to make it look nice. Because the way this course is going to work is we're going to be exploring math that we're just learning about, and being able to visualize it is the key. Like being able to see it is going to make you understand it better, I believe. So our starting point here is, can we make graphics? Can we bring things, can we make it visible? So that's our first thing I want you guys to work on. So yeah,
Is this just for classwork?
Yes. Yeah, you want to close it with code. So this is where text goes. That's good. And then this should be a curly before it, maybe.
No.
So that's a closing to what? Well, yellow shouldn't be. Happy with that? No?
No, just reconsider.
Let's see, epilogue, we have the open.
The epilogue was.
This is, there we go. Okay. Maybe, yeah, that's not good for this graph, try.
And how do you download it?
So you can access your cloud file. That was better. And then hopefully automatically save. I think you can go to file here, open as PDF, so you can generate a PDF of what you just created. So like once you do your homework thing, you can show me the PDF. I want to see the code that you do.
Yeah, I sent it to you.
You can send it to me, or you can bring it in on your computer tomorrow, and I can just look at it, or I can help you get it off.
Or you have a Google Classroom.
Yes, yeah.
Is it just last year's one?
No. Oh, are you guys not in the Google Classroom yet?
no.
You didn't have laptops the first day.
And you.
Read it out.
And then I just forgot to do that. So, okay, I'm going to close this. And let's get you guys into it. I'm going to have to blur out these like classroom codes and stuff. So we don't get randos popping in. Okay, so if you are not in this class, which I imagine none of you are, this is our classroom code. All right, not bad. I was hoping we would go a little bit further today. I was hoping to take what we just made, copy and paste it, and start doing like 2 functions and then 3 functions. But we got pretty close to covering what I wanted to cover. Are you guys in? Very good. Any questions? I think that's class, right? All right, you guys have a great day.
Thank you.
Mm-hmm.
Oh, look out.
So messy.
I sent my PDF in.
Okay. Well, I want you to make a new, like a different function, style it differently than what we just did. That's your homework. Very similar to what we just
Maybe
did.
we can post in the classroom on the web about exactly the homework is.
Yes, yeah, that's a good thought. Thank you.
Thank you for your answer.
You too.